Wow. Hi, everyone. Thank you for joining today. My name is Amanda Tan, and I'm the Associate Director for Research Development at the MSCC, and I'm joined today by my colleague, Pavan Nara, who is also our AI Technical Specialist. Today, we're going to talk about AI in research and education, specifically what it does, what it doesn't do, and how to think about it in a way that is actually useful. I'll start grounding us by how to think about AI in this space. Then Pavan will walk through how these systems actually work and how to use them more effectively. The goal here isn't to cover everything. It is to give you a clear mental model so you can decide where and how AI fits into your work and where it doesn't. So here's how we'll spend our time today. We'll start with why AI matters in research and higher education, and then what AI actually is and what it isn't. Then we'll talk about how and where AI can help, where it fails, and how to work with it effectively. And finally, we will talk about what this means for your institution and how MSCC can help with what comes next. Next slide. So why are we talking about AI now? AI adoption is happening really fast across research and education. But what's interesting is not just the speed, it's how people are actually interacting with it. Right now on most campuses, we're seeing a mix of curiosity, pressure, and confusion. There is pressure to do something with AI. There's curiosity about what it can actually do. And there's a lot of uncertainty about what's real versus what's hype. At the same time, these tools, these AI tools, right, like ChatGPT, are extremely accessible. Anyone can open a browser and start generating outputs. You can do it just through your laptops. You can even build AI tools. Now, here's where things get tricky. Because these systems produce fluent, confident responses, we tend to assume that they are correct. We expect certainty, right? Even though these systems truthfully are probabilistic. And what does that mean? What do I mean by probabilistic? It means in simple terms that these systems are generating the most likely answers based on patterns. It's not actually verifying what is true. It's just making very good guesses. But a good guess is not the same as a correct answer. And when we forget that the answers that we're getting are just an estimate, we start trusting AI in ways we shouldn't. And that's why we're really having this webinar and this conversation. Next slide, please. So, what does AI really mean in this context? When we say AI in research and education, we're really not talking about something that's abstract. We're talking about tools that can help you summarize research, analyze data, draft content, and explore ideas faster. So, we're talking about tools that can support your work. It doesn't understand your field, right? It doesn't know, but it doesn't understand your field. It's not a specialist. It doesn't know what counts as valid or rigorous and cannot replace your expertise. So when we talk about AI, what we mean is that AI are a set of tools that can help you move faster, but it still depends on you to think. Next slide, please. So, why does AI or AI adoption in research and education, why does that feel hard? This is where things get really complicated. It's not just the technology, right? Technology exists, but it is also the environment in which you're adopting AI. You have limited infrastructure, limited time, and limited staff bandwidth. At the same time, there is that pressure that I talked about adopting AI. And internally at institutions, there are a mix of skepticism and confusion. Faculty don't fully trust it, administrators don't fully understand it, and the risks like hallucination and bias, you've probably heard these terms, and we're going to talk a little bit more about it, those are real. So, adopting AI really just amplifies confusion if there isn't a clear way to approach it. And that confusion doesn't stay abstract. It's not in a layer up here. It shows up in very real ways in the day-to-day life of researchers and faculty members. So the best way to think about AI is that it's a tool. Now, I'm going to present an analogy here, just kind of like a microscope. We don't trust a microscope because it's smart. We trust it because it helps us see something we couldn't before. So AI works in the same way. It helps you see patterns, but you're still responsible for interpreting them. The next slide. So what does AI do really well? Let's talk about that. AI is actually very good at a few things. It can recognize patterns at scale. So if you provide it with a set of data, it can quickly and very easily recognize the patterns and trajectory of that data set. It can summarize and structure information. It can also compare ideas very well. So what AI fundamentally does is that it helps you explore different directions. So it is a powerful assistant, and that's the key word, that it is still just an assistant. Next slide, please. So let's talk about what AI cannot and should not do. And just as important, AI shouldn't be able to guarantee the truth, right? It cannot guarantee the truth. It cannot understand context. So if you give your AI a bunch of data, it cannot understand the context of the data the way you as a human person does. It cannot replace expertise, meaning that you, as the human, have the background to understand the context, right? You understand the science questions behind it. And AI cannot take responsibility. So the human in this part remains accountable. The AI is just a tool to assist you, but the judgment and final decisions belong to you. You are still accountable. And that's fundamentally to say that every AI output requires verification. Now, so we've talked about how to think about AI, and I'm going to hand it over to Pavan, who will walk through how these systems actually work and how to use them more effectively.
Yeah. So until now, we actually talked about what is AI and how, where it actually breaks. Now let's shift to something more deep and what is about. It is how do you actually think with AI? So most of the problems that we face with AI actually don't come from the tool. They actually come from how we approach it. So right now, how we are actually working with AI is we are moving from asking to answers, but we have to ask better questions. So how do we ask better questions? We clarify our scope, we clarify our goals. So what do we mean by clarifying scope and goals? You have to make sure that whenever you have a conversation with AI, you mention this is what I want to reach. At the same time, you have to limit that what is the scope of your project? Are you looking to do a complete overview, or are you limiting yourself in a certain period? So that's how you actually keep boundaries for your AI so that it does not go into all of its trained data and give you responses from it. At the same time, we should also move from automation to assistance. How does that happen? You should provide the right context and constraints. So as a researcher or a faculty or a staff member, you do have your own view. But whenever you have a conversation with AI, you should give it the complete picture that you have in a way that you are providing the right context and the right constraints, saying that these are the limitations that I'm actually facing. And you should show those limitations in your research as well. At the same time, we of course have, move from implicit trust to verification. Of course, we don't trust the output of an AI, but how do we actually do it? We do it with a validation criteria. So what do we mean by a validation criteria is that, a predefined standards or measurable standards so that whenever an AI model performs, you are evaluating it whether it is accurate, reliable, or safe. So in this is a process that has to be going so that the model, when you ensure that the model can solve the problem in the intended way without giving you any risks or, hallucination or bias. So all these things happen when you are actually using AI as a black box. Now, using all these instructions and how you're following your structured approach, now AI is your research tool. Now you are using that research tool to transform your research into more efficient. Now we have understood how to think with AI. Now let's look at what is the best mental model when we work with AI. So the better mental model is not just that we cannot just say that AI can do literature reviews. But instead of that, you should think about where are the different points where my logic can actually break. AI does provide you summaries. Is it true? Are they actually legit? So you have to make sure that are you checking where can it actually break? Because given a huge piece of summary, did it summarize all the efficient gaps or did it left out anything? So you have to make sure are there any breaks in the logic that AI has provided or not? At the same time, you have to look at the chain of evidence as well. So in a given conversation, AI does back its responses with some resources. So you have to make sure that are those real resources or are they something that has been created on that point. At the same time, you have to look at what you have to verify and what is already verified as well, whether it be citations or references. AI can create things in such a way with 100% surety saying that they are the real ones. It can create references in a way that it will show you a publisher, it will show you a title, different author names, but at the same time they might not be real. So you have to understand what you should verify and what has to be verified at the same time. When you look at in this sense of mental model, now you are driving the analysis, whereas AI is following you. So AI is not the source here, you are. Now let's look at a small example how this can be done. As you see on your screen, there is an output and then there is an input and an output. As you see in the input, it's a basic prompt asking for prompt engineering techniques in cybersecurity. Now, as you see in the output, it is actually good. It looks really academic. It can be a part of a paper, of course, because it defines what is prompt engineering and how it has been emerged at the same time. You can see that it does say in early studies of prompt engineering and etc. Now, it does really, really great. Now, I'm actually confused that this is doing great, but what is more needed that? Now, as you look at the text, it looks very generic. It does say prompt engineering and stuff, but I don't know whether it can provide the right references and does it identify the gaps? What is the issue that is actually pressing here? So that is why what we're actually saying that if you are using this generic prompts, you can get an output, but it will also be a generic output as well. Now let's look at an improved prompt and how can the output be. Now, as you see on your screen, this is an improved prompt. So what are we actually doing is we are saying what is this task in hand, and at the same time, we're also scoping it down so that say this is an initial version, this is not a final version as well. At the same time, we are limiting our research itself to a period of 2020 to 2026. At the same time, you're also mentioning that focus on researchers which focus on solving the problems, not of just cyber threats. At the same time, as you see, it follows with what is the goal and how are you actually validating your data with papers which are published in unique conferences and etc. So in this way, as you see in the output has a title, the output has an abstract, at the same time it has various structure sections. At the same time, it does provide you citations and references. Of course, we are coming back to the point where you have to verify your citations and your references. But as you see, the output quality has been improved. So what did actually change? I'm actually using the same model. I'm actually trying to solve the same problem. So what has improved is the way I've provided additional context, constraints, the different scope and goals. In this way, AI has been able to identify that what is the problem, how can I actually solve it, and what are the limitations as well. So in this way, as we have just seen that whenever you have a conversation with AI, first define a scope. So once you define a scope, you are limiting the question and the response as well. Once you do that, you'll get a response, which is an AI synthesis, and use that summarization so that it is an initial version. And after that, verify the results. Make sure you verify the results with actual summaries because AI can hallucinate and can follow as biased. Then finalize with your final thoughts saying, okay, these are the right ones and how did it actually help you? Now we do understand how to think with AI. Now let's go a step ahead and understand what does AI mean in research. Okay. So as you see, AI can be anything. AI is actually a big, big, broadest concept. Now, what do I mean by AI if I'm talking to you? So whenever someone says that I want to, I'm using AI. So what do they actually mean? So before going into these terms, let's try to understand why do we need to understand all these terms that we are going to learn in this presentation. The first and foremost reason is that it is a common language which you can talk with your peers, with your faculties, with your staff, with your students, so that you have a common ground now. So once you understand these terms, even though the abstraction layer changes or the architecture changes, now you do have a common language. If the architecture changes, it does have similar elements. So that helps you have a common conversation and things. For example, let's take you're using a delivery robot. There can be different organizations or companies which produces these delivery robots. But once you understand how does the internal systems work, even though it's a different product, you will able to use it. So in the same way, that is why there is a need to understand what are the different terms. So let's come back to what is AI. So when I speak about AI, for example, if someone says back to me that I'm actually using AI in my research, so my first question will be, what do you mean by AI? So whenever they respond back to me, if I have to understand that, I need to know these terms. So as AI is the broadest concept, it is where you can call it as a field where of building systems that can perform tasks as humans do, such as reasoning, it can be language, it can be decision making. AI cannot do all these tasks by itself unless until it learns. So how does it learn? It learns using machine learning, which is a subset of AI. So it is a way of building AI systems where the model itself learns the patterns from the data instead of you directly saying it. So, for example, if someone knocks on the door, you have to open the door. So, you should not say that to a machine or a model that every time X happens, do Y. So, you cannot be with a model all the time. So, that's why you will train the model using machine learning. Next comes is deep learning. Deep learning is actually uses a multi-layered neural networks to learn complex patterns. So it is not about designing neural networks, it is specifically deep neural networks. So it's a technique. Now let's go back to foundation models. So what does foundation models mean? We have been listening the word foundation models here and there. So what does it actually mean? Foundation models are models that have been trained on huge data sets that can adapt it to different tasks, not a singular one. So there are different types of foundational models. It can be a language model, it can be a vision model, it can be multi-model model. Now let's look at what are the different types of why does these distinctions matter, and followed by what are the different types of foundational models as well. So why do we need to know this distinction? So whenever someone speaks about AI, now there are differentiations such as machine learning, deep learning, foundation models. Now, when you go to machine learning, the main role that plays is data. If your data is biased, the outputs will be biased. If your data is not clear, your output can hallucinate. The model that can hallucinate does not provide efficient answers. So now you understand that whenever someone is using AI or ML, so you have to make sure that the data is clear and good. We'll see how data can be cleaned or what are the different sanity checks that you have to make sure. We'll see that. And followed by deep learning. Deep learning is a technique as mentioned. So as your compute increases, as your data volume increases, you have to improve your technique. So that is why we mentioned about saying that. So deep learning is just a technique, but at the same time, make sure that if you are increasing your volume, you are also changing your techniques. Now it comes back to foundation models. As mentioned, foundation models have been trained on a huge types of text. Now, as it is a general purpose model, it can be imperfect. It has errors, it has biases. So you have to make sure that you're fine tuning it for the right task. Now, understanding all these also understands the limitations that's come with. So that's what these distinctions actually matter. Now let's go ahead and understand what are the different foundation models are there. Foundation models, as mentioned, have been trained on different paths. So an LLM can be a foundation model, but a foundation model cannot be an LLM because a language model which focuses on only single type. For example, language model focuses on chat, writing code, or scripts, or writing text, or summarization. Whereas vision models focus on image recognition and object detection. And when you go back, speech models handle transcription and voice generation, and etc. So as there are different models, so whenever you are actually working with a model, there are three questions that you have to come into mind. What type of model is it? Is it an LLM? Is it a vision model? Is it a diffusion model? Or what? At the same time, how is it actually released? Is it an open source? Is it an open weight or a proprietary? So open source and open weight are usually used vice versa. Let's try to understand what those are. An open source model is where everything is actually, shared as open. So you can look inside, you can change it, you can use it, you can do whatever you want to run it wherever itself. It can be on your system, it can be on your phone, it can be on your laptop, etc. But whereas open weight is that you can use the model itself, but you cannot see it, you cannot change it, how it was actually built. Now that's where the third variation comes in, which is a proprietary model. A proprietary model is completely closed. You can only use it via the company's service. So you cannot see it, how it works, how it has been designed, and etc. Now, such as it can be, GPT-4, Claude, and Gemini. Now, how do you access this? That is via API, locally, via cloud, or on device. Now you do understand what are the different foundation models, what is AI, what are the different types of AI, and what are the limitations that come with each of its AI. Now let's look at how does these models actually learn. Let's look at that. So before going into it, as mentioned, so whenever you are giving a model to learn something, there are two types. One is supervised, as one is unsupervised. So unsupervised learning is more about where the model has been given unlabeled data and it has to find its own. So let's go back and understand what is labeled data, what is unlabeled data. Labeled data is where you have the inputs and so you have the right outputs, correct outputs. At the same time, unlabeled data is only inputs. You don't have the outputs. So when you give labeled data, which has inputs and outputs, you are going with supervised learning. A supervised learning where you are saying that for this input, this is the right output. Now you give another input. Now try to find the output for that. So that is what supervised learning is. Whereas unsupervised learning is about you give the inputs, you need to find the patterns yourself. So the model itself has to figure out how to detect patterns. There is no correct answer here. It is completely about discovery. Whereas supervised learning, the goal is to understand, to map between inputs and outputs. So that is how a model actually learns. Now let's look at what are the different types of AI. The one is predictive AI and one is generative AI. So when you look at this, there are a couple of similarities. One of the similarity is that both of these AI actually use data and learn patterns from it, and it uses probability under its hood. And at the same time, both of them actually predicts. You might say that even though both predicts, what is the difference? That is where the actually, the twist is in. A predictive AI actually predicts a specific value or, a specific number, or it can be a specific label if we speak in terms of data sets. Whereas generative AI produces new data samples. So predictive AI is where you learn the relationship between input and output and you predict the next likely answer. So it is more about having a fixed question. For example, uh, is this, is this the phone or is this a hand? So you're trying to understand a yes or no. At the same time, what is the price of this MacBook? So it's a number. So at the same time, these are the types of questions that predictive AI responds. So the output is already predefined and it is constrained. When you come to generative AI, it is about learning the underlying structure. You are generating new responses that resemble the training data. It can be, ChatGPT and etc. So to be very, very brief, predictive AI chooses an answer, generative AI creates an answer. Got it? As simple as that. Now let's go to what does context window mean and what does memory mean? Let's come back and understand why do we actually need these two. So whenever you are having a conversation with me, let's take that we two are having a conversation now. Let's take we had a conversation 10 days ago. You might remember that. If we had a conversation 10 months ago, I might not remember it. So, uh, a context window is completely about that. So it's a total amount of text or, which is measured in tokens that AM model can actually see and consider at one time. So as I said, at one time, it does not include only your prompts. It also includes your instructions, your conversation history, any documents that you actually shared, or the model's replies itself. So for the previous prompts, what has it actually replied? Did you add any documents? Did you give any other instructions? So all these come under context window. So it depends on the model, what is the capacity of the context window of that model itself. Whereas memory is where you store everything, such as it can range from your chats, your data and etc. So it doesn't mean that if as it has in the memory, it does not remember tomorrow. It depends on the context window. So whenever you have a conversation with your AI or LLMs, keep that in mind that if it does not recall what is happening yesterday, it is limiting your context window. So that is what the key take here. Now, as we understand what are the different models, how can we use it? How do train an AI? And what are the different types of AI? And what is the difference between context window and memory? Now let's look at a key factor in models, which is datasets. So whenever someone says that we are using AI on a specific problem, you should also think about what dataset are we actually using, because AI does not fix the data itself. It uses the data. So in terms, it actually scales it. Now, as you're using the dataset, you have to make sure that the dataset is clear, structured, and clean. Now, you have to make sure how do you actually do it? A data sanity check. So, how do you perform a data sanity check? First, you have to understand what are the different variables in your data set. Is it plausible? What is the real world meaning of that variables or terms? Because if the data set does not mean in realistic terms, the model which has been trained on the data set also will create unrealistic terms, which is not real when you're working with efficient research. At the same time, you should also look for outliers. So what do we mean by outliers? Something that doesn't make any sense, some missing data, or duplicates or difference in measurements. There are different types of outliers. So you have to make sure that you understand the variables and the variables are realistic and the values are realistic. And you have to make sure your dataset does not have any outliers. Now, at the same time, you have to finally check are there any edge cases, something which turns out because AI model does not learn if you actually miss something like that. So you have to make sure that your dataset is very clear. So if something is biased and incomplete or missing, your model will learn that and it will actually repeat it. Now we understood what are the data sets, how to clean it, what are the different AI models. Now let's look at one of the key term, which is called embeddings. So models actually doesn't understand, words and the meaning of these words. They understand numbers. So embeddings is how sorry yeah embeddings is how we convert words and its meaning into numbers. Similar ideas are usually placed together. For example, talk, talking, talkative, talk, talks. All these words have similar meaning. Although they represent different tense and different variations, they do have similar meaning. At the same time, typewriter is a different word. So these, talk, talkative, all these words are grouped together, whereas typewriter is another word. So whenever you talk or, whenever you have a conversation with your AI, if you're actually giving out a new word and your model doesn't know it, what it actually does is it goes back to your vector embeddings and it looks at the representation. If there are similar words which has similar meanings, it will pick that and it will use that meaning. So that is how a model actually understands it. So that's what allows your system to find relevant context even though the words doesn't match. So why do we actually need embeddings? As mentioned, so now if you have embeddings, you can search beyond exact terms. You don't have to repeat the same term. For example, you don't have to say that this is a wallet. You can say it a purse. It's a collection of wealth. So there are different ways to say it. So now you can use different terms. At the same time, you can group similar ideas and you can scale to larger collections as you have. Now we understand that how a model actually understands different terms, different words, different sentences. Now let's go to how to use these embeddings to a RAG. Let's do that. So as mentioned, uh, the reason these embeddings matter in our research is that it actually lets you or the system that you're actually using to find relevant materials. So why do we need to find relevant materials? So AI models, naturally can hallucinate, can be biased. So how do we actually decrease that? I'm not trying to say that we'll completely eradicate it, but how do we decrease it? We actually decrease it by using a RAG model. RAG model, to be very clear, is a simple in concept. Instead of asking the model for a response directly, we first retrieve relevant information. Once you retrieve the relevant information, you add it and you add that context to the prompt. Now, then only you get a response. It doesn't make a model smarter, but it does make it more informed and having additional context. Now you do understand how it is actually getting information and what happens when it uses it. So it gets information using embeddings and it represents it using a RAG. Now let's look at how does a chatbot actually work. So when you use these chatbots, so there are four different elements very similar to the RAG model that we just mentioned. One is the user. It can be a person, an organization which is trying to use the model. Now, every chatbot does have its own embeddings, the retrieval that it actually uses, so that AI retrieves this info to convert the user input into embeddings. Now, it can be different relationships among the concepts, and it helps the model understand what is the content, what are the relationships, and etc. Now you have the main engine or the brain, if I have to say, which is the language model. So it actually processes the embeddings, the input, and uses its own knowledge that has been trained on its data set, and it gives you an output. That is what an answer is. This can be a grounded or ungrounded response. So it depends on how you actually build the chatbot. Now we have learned, how do chatbots work. Now let's look at how does actual ChatGPT work. So ChatGPT actually uses a pre-trained model. There are different types of models. So you give a prompt, it gives back to that model, and you get a response. So whenever you give a context or a prompt, it takes it and it uses its trained knowledge and try to guess an answer to your input, and the response can be fluent. At the same time, it is not guaranteed that every time it actually gives you back with grounding or resources backed by it. So unless and until you give documents or any sources, it does not give you grounding. Now let's look at, now we understand what happens with the chatbot, what happens with ChatGPT. Now let's understand what does building a chatbot actually requires. So building a chatbot is not, you're clicking the button for the model. You're not actually doing that. You're actually deciding what data is getting used. How are how is your model, retrieving that data? How is the model understanding your input? How are the responses are being generated? So there are few components of it, such as the language model, which is the core engine. You have to make sure that your model is, you know has been dynamic and at the same time has been learned on the data set, which is clear, which does not have any bias, and it cannot hallucinate. And at the same time, you should have retrieval, because finding relevant info using embeddings can help your responses. And you should also inject context, because finding this relevant context can help the response having more grounded responses. So this is what building a chatbot actually implies. So it is actually important that all these are actually verified. Now we have understood so far what are the different terms, how can they actually involve, for example, different models, how to clean a data set, how embeddings work, how does RAG use these embeddings, how to build a chatbot, what are the different things that you have to keep in mind. Now let's look at a final distinction, which is training and inference. So when you look at training, most of the time we might not be involving in training all the time. Training is where the model actually learns. It might be machine learning, neural networks, and etc. Inference is where you actually use it. Most of us naturally don't actually train models, but we use inference every day. Now, so the difference between AI and building with AI is not actually intelligence. It's about control, it's about having the grounding, it's about being responsible for the data or the output that AI has generated. Now, three things to remember. One is that always look at what the patterns that AI is actually providing. You should not look at AI to define the truth. AI defines patterns and scales the patterns, but it does not define the truth. At the same time, whenever you're having a conversation with AI, make sure you provide the context, because AI responses depend on this context heavily. At the same time, whenever AI has generated content, you are responsible for it. Humans should have the accountability for all the content that AI has generated. And how to communicate with AI. So, whenever you give a prompt, make sure that you have your instructions and add some additional context to it. Give as much as information as possible so that it can give you a best grounded response. At the same time, remember that the quality of your input to an LLM is the quality of the output. And how you think, for example, use AI to support your reasoning, but AI should not replace your reasoning itself. At the same time, try to improve your prompts iteratively. Try, once you get a response, if you don't like it, improve the prompt itself. So using this iterative process, you'll actually get to do very good prompts. Now let's see what Amanda has to say about how institutions can do this.
Great. Thanks, Pavan, for that technical insight. So, everything we've talked about so far probably makes sense conceptually, the technical aspects of it, but this is where things tend to break down in actual practice. Most AI guidance assumes that you already have the infrastructure in place, you have the data, access to high quality data, and the people with time and expertise to help build your AI project. But for many institutions, especially across the MSCC institutions, that is just not the reality. You might have one or two of those pieces, but rarely all three. And sometimes many institutions don't even have any of them. So what happens is that, people, researchers, faculty members try tools. They may try to run a pilot, like a chatbot pilot, but it doesn't become reality because it's not sustainable because they're lacking in one of these three things that help build out AI in practice. And that's not a failure. It is fundamentally a mismatch between what building out AI capacity requires and what is realistically available. Next slide, please. So this is the gap that we at MSCC are here to help you address. We do not expect you to just figure this out. We can help define use cases that actually make sense for your institution. So my colleague Pavan here is our AI technical specialist, and he is here to help you understand what are specifics of your AI problem. We can connect you to infrastructure. We have a team of cyber infrastructure facilitators that will help connect you to national resources, to local resources. And we focus a lot on hands-on work and workshops, and not just teaching you the concepts. So fundamentally, we provide guidance along the way. And the goal is not just exposure to AI. We're not saying, hey, this is what AI is, here are the tools, go crazy. It is to help you move from should we use AI? How should we be thinking about AI to actually something that's concrete, to actually building something that works? Next slide. This session today, this webinar is just the starting point. We have an AI readiness webinar series that consists of 3 other webinars, and the rest of the series builds on use cases, infrastructure, governance, ethics, and scaling. The goal is to move from awareness of AI to readiness and implementation. Because AI is not just about the tools. It really is about knowing what to build, how to build it, and do it responsibly. So next. In the next session, just a preview, we will be focusing on actual tools. We'll focus on workflows and things that you can use right away. And this is where things becomes more hands-on. We will be talking a little bit more about tools like NotebookLM, and we will also teach you how to build agentic frameworks with GPTs. Finally, we will be happy to take any questions, and I'm just going to jump straight into the Q&A where we have 2 sort of related questions, and they are really around, they're kind of the same concern from 2 angles. So one is about, let me see, what are the questions? One is about the microscope analogy. It falls short of the expected area of fidelity. And the question was asking, how do we really think about using things like summarization when AI can hallucinate and produce answers that are not structured in reality? And the follow-up question to that is how can we use AI for literature review when we do, because when we do a literature review, we know what methods we are using to locate the sources we decide to ultimately include in our review. So when we use an AI to help with literature review in the way described, how do we know what methods it is using? And how can we be confident in the quality of the search process? So that's a great set of questions. And they're actually getting at the same core issue. AI doesn't operate like the traditional research process. It's not doing a systematic search the way we have been, right? By looking at citation networks, refining keywords, evaluating sources. And it's also not guaranteeing accuracy because it's generating outputs based on patterns. There is no truth behind how AI does its work. And Meg, I think you are absolutely correct, and right that AI functions as a black box, which is why we keep circling back to the way you identify and evaluate sources, that still needs to stay intact. AI can help you synthesize across papers. It can help you select those papers, compare the themes or surface questions that you might want to explore further, but it shouldn't be the thing that defines your literature set. And it shouldn't be something that you trust without verification. So the goal isn't to replace the research process with AI. It is to use AI within that process while relying on your methods and your judgments and your own standards to ensure quality. We do have one more question, and I'm going to punt this over to Pavan. The question that we have for you, Pavan, is can AI help me locate and access specific data sets relevant to my question? For example, I'm doing a research on impact of zoning code in cities on light pollution. So can it access the zoning codes of a specific city to get the data related to light intensity, light locations, and light levels at night from the zoning ordinance?
That's actually a great question and a great use case at the same time. So yes, AI can help you locate, data sets and sources, but usually it cannot directly access or, extract authoritative zones, as you mentioned. May it is light intensity data, etc. So it can connect you to the right tools, the right databases and public records. So to be very precise, AI can help you identify it, and where to look. It can be GIS portals or different code databases. And what I'm trying to say is city code databases or any data portals. But AI should not be treated as the data sets itself. You still need to confirm that the city zone's code is currently right. At the same time, the GIS layer that you actually mentioned matches the records, and at the same time that the light intensity measures are what you actually need. It does not represent previous data, or it can be artificially generated as well. So you have to make sure all these by yourself. AI cannot do that, but at the same time it can direct you to it, but it cannot get you the whole data set.
Great, thank you. Um, it looks like we don't have any other questions and we are almost at time. So again, thank you all for joining this webinar, and we do have our contact information on this slide here. Again, if you have super technical questions, you can reach out to Pavan or myself, but Pavan is more likely your technical support. And we do hope to see you on our next session about AI tools on May 20th. And with that, this is the end of the webinar. Thank you again all for joining, and we'll see you in a few weeks.
Thank you so much for joining and taking your time. We looking forward to come back to our mailboxes and reach us out. Thank you.
Thank you.